Hi everybody, today we are gonna finish the rest of section 2.3 and section 2.4. And also quiz 4 is on this Friday from section 1.6 to section 2.2. So section 1.6, section 2.1 and section 2.2. In last class we talked about the two forms of rate of change, or two forms for the derivative. So the first one is the general one, which is f prime of x. So this one read as f of prime of x. And the second one is df dx. So this is the general one, that means the derivative of a function at x. So when we are given that x equals to a, so you can just plug in x equals to a. So the first form will be f prime of a, but the second form is slightly different. That is, first you have to keep df dx, and then just use x equals to a. And this one read as df dx evaluated at point A. And similar, the unit of this one, the unit of measure for a rate of change, or you can just say for derivative of f prime, it's just the output unit per input unit. And the last part is the interpretation. Interpretation try to answer the four questions. First one, because the interpretation for derivative or for percentage rate of change is only, both of the two definitions are used for a single point. So the first one, what, refers to a single point, and second one refers to the output description. Third one, increasing or decreasing, by how much. By how much you have to include the correct unit. The unit depends on which model your derivative or percentage rate of change. Then the second, this table, this box shows you the difference between the average rate of change and the rate of change. So you can see average rate of change, this definition is used for an interval. For example, if we are given an interval a, b. So this interval means x is greater than a, less than or equal to a, less than or equal to b, not f of x. So the first one, average rate of change measures how rapidly a quantity changes. First one, on average. And second one, between 2 points. So 2 points means an interval. And then so you can see the third condition, average rate of change requires 2 points. 2 points means an interval. And graphically, in graphically the second one, graphically, average rate of change finds the slope of the secant line between 2 points. So secant line between 2 points. And then let's compare it with the rate of change. So you can see rate of change first. The rate of change measures how rapidly a quantity is changing at a single point. So derivative is used for a single point. And then next one, graphically, is actually the slope of the tangent line. Slope of a tangent line at a single point on a continuous and smooth graph. So derivative graphically means the slope of the tangent line at a single point. And the condition for rate of change requires a continuous function at a point that is not a sharp corner. So sharp corner is like this one, and does not have a vertical tangent line. So later we will talk about more details about this part. Sharp corner and the vertical tangent line exist. So next, let's try to finish it. Example 2. So my suggestion is to pause the video here and try to do it by yourself, then check the solutions. So now I'm gonna just finish example 2, but you have to do it by yourself first. Example 2, this one shows you the Apple Corporation's annual net sales, and output unit is trading dollars. So over an 8-year period, then we know the input unit is year. And the question A, find and interpret the average rate of change between year 6 and year 9. So first, let's find the year 6 and year 9. Year 6 and year 9. So you can see here, we are given the corresponding output value. And similar for year 9, we are given S of 9, which is 32.48. So first question, average rate of change between year 6 and year 9. So we can just use 32.48 minus 13.93 divided by 9 minus 6. So the number is 6.183. Unit is trading dollars. Unit is output unit per input unit. Output unit is trading dollars. Input unit is year. So now we are done with the first one. The second one, interpret the average rate of change. So the interval is from 6 to 9. So the first question 1, we can just say between year 6 and year 9. And then output description. Output description is just the blue part, Apple Corporation's net annual sales. So let's copy this part. Next one, we can see the number 6.183 is a positive number. And this number means the average rate of change. So we know a positive one means increasing. So you can just say increased. So the third question, increased or decreased. The last question, by how much? By how much, you just use the number and the unit. Increased by 6.183. Unit is trading dollars per year. Then we are done. And the second question, question B, find the slope of the graph at point 6, 13.93. This point, this blue point. So we know a slope of the graph, a slope of a single point in this function graph actually means the slope of the tangent line at this point. So actually, let's try to draw this line, which is the right line. The right line is actually the slope. The red line is actually the tangent line. So the derivative at this point is actually the slope of the tangent line as a single, the slope of the right line. So we can see that the right line, we are given 2 points. The first one, 13.93 is given. But we know if we want to calculate for the slope of a line, we have to know at least 2 points. But for a tangent line, we only know 1 point. Then that means actually you have to know the coordinate of another point in this line. So you can see here, the function graph shows you the other point, which is 4.91. So that means we are given this point. So now we know 2 points in this tangent line. So we know how to calculate for the slope. Then for question B, we just use 4.91 minus 13.93 divided by 4 minus 6. So this time we got 4.51. And then for this one, we can use two notations. The first one we use f prime of x. The second one df dx evaluated at x equals to a. So the first form is just pay attention. This time the function notation is s of t, not f of x. So it should be s prime of 6 equals to 4.51. And the second one, ds dt. When t, pay attention to here, it is t, not s equals to 6, but t equals to t equals to 6. 4.51. Then we are done. So question C, write a sentence of interpretation for the derivative in part B. So for the derivative, this one, first try to explain what does t equals to 6 mean. So t equals to 6, it means at the end of year 6. And then output description. were increasing because the value is positive, were increasing. Increasing by how much? 4.51 unit is trading dollars per year. And question D. Write a sentence of interpretation for the percentage rate of change. For the percentage rate of change. So the interpretation is just everything else is the same, let's say. So I will highlight this part, and then we know this part is the same. Okay, and then the difference is the red part, is the rest part. So I will just say everything else is the same, and then this time we're increasing by. So the percentage rate of change is the unit is percent per input unit. Percent per input unit is year, percent per year. And for this one, you have to use the formula for percentage rate of change. And the number, the correct answer is 32.376% per year. And the next one is, okay, last class we haven't finished example 3. Example 3, so first, we know C of 0 equals to 124. So that means C of 0, which is right here, equals to 124. So we are done with the first one. The second one, C of 4 equals to 252. So 252 right here. And then C prime equals to 48. So that means at this point, the function is actually increasing. The function is increasing. And then let's see the fourth, 1, 2, 3, 4, the fourth one. The function is increasing most rapidly after 4 hours. So after 4 hours, which is right here. So we know this point is 252. This point is increasing most rapidly. So we know the function is increasing by using this one. We know the function is increasing at this point, increasing the most rapidly. That means actually this function at this point is actually an inflection point. And then the next one, we know this is an inflection point. Then we are done with the first one. The fifth one, the function has a relative maximum after 8 hours. So 8 hours, we know here is a relative maximum point. So first, let's try to connect it. This is an inflection point. Then let's see. Then, so 8 is an relative maximum. Then we are done with the fifth one. And then let's see the third one. F of x after 24 hours is 35.9, higher than it was when the dot was administrated. So that means actually when h equals to 0, we have 124. So 24 hours later, when h equals 24, the C of 24 is actually, that means C of 24 equals to C of 0 plus 35.9. So C of 0 equals to 124 plus 35.9 should be around 159.9, so around 160. So we know when h equals to 24, the C of h should be around 160. So that means it's about here. So we are done with this one. And the last one, between h equals to 8 and 24, f of x is declines at a constant rate of 14. So this one actually just means from 8 to 24, the function is a linear function. It's a decreasing linear function, and the slope is about 14. So actually, you can just connect the point 8 and point 24. Then we are done. So the last part of this section is, you can see we have a table. This table will be on quiz 4. And just pay attention to the percentage rate of change. So one question, I didn't show you the details. That is question D. This value, actually, you can just use the last formula. So this actually, that one was an exercise. So the percentage rate of change unit is percent per input unit, not output is percent per input unit. Then the rest of the percentage change, the unit is just a percent. So next, we're going to start section 2.3. Section 2.4, excuse me. Section 2.4. Section 2.4. Rates of change, numerical limits, and non-existence. So still, this section is talking about the rate of change or the derivative. So last section, we've learned the rate of change. We've learned one method to estimate it. That is, for example, if we are given a function graph and ask you what is the derivative, what is the rate of change at this point, A. So the method we can use is first, draw a tangent line. Because the function at that point is concave down, so the tangent line is actually above the function graph. So first, draw a tangent line, and then try to calculate for the slope of the tangent line. The slope of the tangent line is actually the rate of change at a single point A. So, but we know for the slope, we have to know at least 2 points. So normally, if you are given the other point, let's say the coordinate is AB, then actually if we know 2 points, 2 out of the pairs, then we can calculate for the slope. So that's the method we've learned in last sections, how to get the rate of change at a single point A. And then this section 2.4 will show us a new method. So let's read the first paragraph. The rate of change, or you can say derivative, they are the same, of a function at input A. So that means when x equals to A, we are given this one. And the derivative is the limit of secant slopes. So this is different from what we've learned. We know the rate of change is just the slope of the tangent line, but what's the difference between the slope of tangent line and the limit of secant slopes? So in the last part, in section 2.2, so we haven't finished the last question. Example 4, so we are going to use it here. For example, in point T, the slope of the derivative at point T is actually the slope of the tangent line. So the blue one is the tangent line at point T, and the derivative is just the slope of the blue line. So let's see. Actually, here we have P1, P2, P3, P4, P5, P6, P7, P8. So you can see that when so first let's try to draw the secant line between T and P5, T and P6, T and P7. This time I'm gonna use the red one. So this is the tangent. This is the secant line between T and P5. So next one, T and P6. And then P and T and P7. The last one. Oh my gosh, they look pretty similar. T and P8. So from here you can see that from P5 to P8, actually the points is approaching to T from the right side. So you can compare the right lines. You can see as like Pi, for example, we use the notation Pi. As I goes to infinity, that means as the point P is getting closer and closer to t, then actually you can see the pattern that the right lines, the secant length is actually approaching the blue line, which is the tangent line. So actually, we can use the idea of the limit. We can just say the limit of the secant lines when the pi is approaching, is get closer and closer to point t, then the limit of the secant length is actually the blue line, the tangent line. Similar, we can say the limit of the slope of the secant length is actually the slope of the tangent lines. So this one I just show you from the right side, from P5, P6, P7, P8. And similar on the other side, we have P1, P2, P3, P4. So that means they have the same idea. So let's go back to section 2.4. So this time, we may have a better understanding of the limit of secant slopes. Limit of secant slopes. The other word is just the tangent slopes. So actually, they mean the same thing. We can use the limit of secant slopes to estimate the slope of the tangent slopes. And then in math language, we have f prime of a, the first notation. So first, ignore this part. Let's just, we have part 1, limit, part 2, slope, secant slopes. Then for example, if we are given the point A, what is the secant slope? So we know it is just the 2 points, f of x, or f of a minus f of x divided by a minus x. So it's the same as f of x minus f of a divided by x minus a. And then the second part is this one. And first part, the limit. So we have to include the limit. Limit. When point x goes to a. Then this one means the limit of secant slopes. So first, limit, second, secant slopes. And the second part is about in a function graph. Graphically, f prime of a is just the slope of the line tangent to the graph. So we use the limit of secant lines to estimate the slope of the line tangent to the graph when x equals to a. So the second part is graphically, the next part is the numerically. Numerically, f prime of a can be estimated by calculating slopes of secant lines between a point of a tangency a f of a and the nearby points x f of x. So later we will see more examples show you what does this mean. And then finding the limit of the secant line nearby, blah, blah, blah. So first, let's try to finish example A. Example A, estimate f prime of 4. For f prime of 4, first, let's find this point 4. 4 is right here, 4, 4. And then question A, graphically estimate. So graphically means you can just use the coordinate in the function graph, and you can see this. The second part is the numerically. So actually, we are using different methods to estimate the same thing. One is using function graph. The second one is by using the table. You can see it right here. So that's the two methods. Graphically estimate the slope by finding the slope of the tangent line. So first, we need to draw a tangent line. We know the function is concave down in this point, so the tangent line should be above this point. So this is the tangent line. Then 4, 4 is right here. You can just find another point in this graph and then calculate for the slope. So here the slope is around 0.5. You may have different answers, it's okay. And the second, because the slope of the tangent line equals to 0.5, then we know the derivative is 0.5 because they're the same thing. And the second one, numerically estimate f prime of 4 by finding the limit of the secant slopes. So the first one, let f of x be a point very close to our target point for f of 4. Then the slope formula is f of x minus f of 4 divided by x minus 4. Or you can just use f of 4 minus f of x divided by 4 minus x. Then we have the same thing. The next one shows you how to estimate the solution numerically. So here, the next page shows you the instructions. So we are trying to solve for this one, f of x minus f of 4. So similar, we have to consider the left-hand limit and the right-hand limit. For the left-hand limit, we use a 4 minus, so that means all the values in the column should be less than 4 and approaching 4 from the right side. So for example, 4 is here. Then you can see 3.9 is here. Then 3.99, 3.999. So actually, all the numbers is getting closer and closer to 0.4 from the left side. And then you can see here we have 8 numbers, and next part we have another 8 numbers. So if you try to solve it one by one, it's very time consuming. And the next page shows you how to get it one time. So here you can see we are trying to solve for the slope, not just the function value. In chapter 1, we've learned how to get the function value, f of x. But this time we are trying to solve for the slope. The slope, you can see here. The first one is similar as before. We use y1. y1 is the function is given because the function is right here. 2 multiplied by square root of x. So y1 is just the function. But remember, we are trying to solve for f of x minus f of 4 divided by x minus 4. But y1 is just the f of x. This is y1, but because we are not done, then the second, we create a new function y2. So after you finish y1, we have the y2, which is right here. y2 equals to y1 of x, which is just the f of x, minus y1 of 4, which is f of 4, divided by x minus 4. Here, pay attention to the parentheses. You have to use the parentheses. Divided by x minus 4, use the parentheses. So we know our y2 is actually what we want, not y1, because y1 is just the function value. And then we use here this step. We use the second window. Next one, we use the second graph, which is the table. So in the table, you can see, then we have this one. Normally it's empty, everything here is empty, but we have x, y1, y2. So in x column, you just plug in first one, 3.9, then 3.99, 3.999, 3.9999. Then we have the corresponding y1, y2 automatically. You don't have to input, you don't have to consider y1 and y2, just type 3.9 to 3.9999 in x, and then we have y1 and y2. So pay attention to the y2 column. Some students will just use y1 as our solution. That's not correct. Because y1, you can see here, y1 is just the function value, but we are looking for the slope. So please use y2. And then similar, because 3.9 is just the left side limit, then we have the right side limit. We use the similar method, 4.1, 4.01, and then we have the corresponding y2. So just plug in the numbers here. Just copy y2, this one, to this part. And similar, the other y2, copy it here. So next, after we finish this one, let's see the pattern. We have the question, the next question. The limit of the slopes of the secant line from the left. From the left means 4 minus. We have to use the 4 minus right here from the left. From the left, that means we have to use the 3.9, 3.99. And then we can see actually the left side is 0.5. Similar, the right side 4 plus, we have to use the right side 4.1, 4.01. Then similar, this time the limiting value is also 0.5. So remember, these two, one is for minus, the other one is for plus. So for the question, no plus, no minus sign, just the x goes to 4. No plus, no minus sign. This time, no matter what it is, this just means a function. Then this time, we know it's just a 0.5. Because first, we have to check the existence. That means we have to check if left side limit equals to the right side limit. This one works because both of them are 0.5. Then we know the limiting value exists, and the value is 0.5. Then numerically, the point is 0.5. So you can see the two methods. The first one is graphically. For the graphically, we just draw a tangent line and then try to calculate for the slope. The second one, we have a table. So in the table, we have to consider the left side limit and the right side limit, then compare if they are equal to each other. If they are equal to each other, then we just say the limit, the slope exists, the derivative exists, and the derivative is just 0.5. Then let's see example. Okay. So let's try one example. Example 2. So this one is about a corporation investment. The first question, draw the line on the function graph of f of t, whose slope represents the rate of change of the future value at point t equals to 3.5. So 3.5 is right here. 3.5, then draw a tangent line. Because the function is concave down, so the tangent line should be below the function graph. Okay, this is the tangent line. The next one, we use the similar method. Just follow the instructions here. Then this time we have, let's finish the form first. 3.49999. Then the corresponding value is 5.392. You have to use 3 decimal places. 5.392, 5.392. Similar for the other side, 5.392, 5.392, 3.5000, 3 triple zeros 1, 5.392. So you can see this time the left side limit just equals to 5.392, and the right side limit is 5.392. So the limiting value exists because the left side limit equals to the right side limit, and the value is, the derivative is just 5.392. And the finish example E. Complete the following sentence of interpretation for the answer to part D. So for this one, just in the middle, part D is, okay, f prime of 3.5. 3.5 just means in the middle of the fourth year. Because from here, from the function graph, you can see 3.5 right here. It's in the middle of the fourth year. So 3 means the end of year 3. 3.5 means 6 months after the end of year 3. So it should be in the middle of the fourth year, not in the middle of the third year. So in the middle of the fourth year, the output description, this is the output description. Output description, because the number is positive, so it's increasing. Next one, increasing by how much? Increasing by 5.392 billion dollars per year. And the next one, find and interpret the percentage rate of change. The percentage rate of change formula is f prime of a divided by f of a times 100%. Unit is output unit, percent per input unit. So the number is 11.333% per input unit, which is year per year. So the interpretation similar. 3.5 means in the middle of fourth year. In the middle of the first year, the output description, which is the value of the investment, is increasing because the number is positive, increasing by how much? By 11.333% per year. So that's all for the this class. And on Friday, we are going to talk about this part and finish example 3. All right, thank you. And don't forget the quiz on Friday.